Hey guys, welcome to another episode of Richie's Robots, episode number 4. And in this episode, we're going to take a little step back. And before we go into further episodes of the sensors and the motors and lights and all the cool stuff that's going to make Plantzilla, I thought I might briefly explain the computer that's running the whole system, the brains behind the whole thing. So without further ado, this is him. And it's a little computer like a Raspberry Pi or an Arduino, and it's called an ESP32. Pretty simple. The name comes from the company. It's a Chinese company called Expressive Systems, ESP. And the 32 is because the processor that is on there is a dual-core 32-bit processor. Really some cool things about this. I'm going to keep it pretty simple, so I'm not going to go too into details. But it has about 520 kilobytes of memory on there that you can use yourself. That's where you put your code and so forth. There's about 420 kilobytes of ROM that it uses itself, read-only memory. The processor runs at 160 or 240 megahertz, so that's how the processor runs. And it has built into it Wi-Fi, which is really cool, so it can connect to your Wi-Fi network, so it makes it a really good computer for the Internet of Things. And it can update databases or web servers. You can even put a web server on the actual chip itself. It has Bluetooth. And it has a whole range of pins along the sides of it. And these pins are GPIO, General Purpose Input-Output pins. And there are a couple that we're mostly interested in for this project. And it has them set as default, so it has them all numbered. But you can change that. You can say, instead of number 1 being this type of pin, you can say number 1 is that type of pin. It's quite handy, but it basically has analog to digital pins, and I'll get all into these pins later on in other episodes into details, but the analog basically allows you to get very more smaller measurements of changes in the voltage. So the water moisture uses an analog pin because it's an analog sensor. It has, instead of digital, which is just on and off, it has capacitive sensors. So you can register a change in the charge. So for instance, when I touch it, I change the charge in myself because we all hold a certain amount of charge, and you can register those charges. It also has these I2C pins. These, in a very simple way, you can buffer and allow you to use things like the OLED display that I used to display the sensors, the moisture sensor in the last episode. But you can put anything on there. You can put faces of people, text, and so forth. But these pins allow you to buffer some information, so you can, for instance, write a line of text down. So that's really it, and it has some power and ground pins. And it has the USB port, and that allows you to that powers it, and also allows you to download your code onto it. So what I'll do is I'll just show you a little bit of code, and then we can see basically how, in a very, very simple way, this computer works. So if you see, I basically printed it out so you can have a closer look. You've got here a voltage pin that you can use for power. Here you've got a ground pin. There's also another ground pin. And you see all these pins are labeled. And basically you can then see what they do. And there's a little chart here. You've got your serial pins, you've got your analog pins, your control pins. And these are by default, but like I said, you can change these as you go along. So for instance, what we're going to do very briefly is we're going to control a LED light, and we're just going to turn it on and off, just to give an example of how that all works. So what we would look at is we would need to use some ground, and what?
Are you playing with your robot again?
Yeah, hang on, I'll be back in it. Just give me a sec. Hey, I'm filming. Go. Right, so sorry about that. Me and my wife sometimes don't see eye to eye on how much time you should be allowed to play with robots, but basically, what I want to do is demonstrate how to control one of the pins. And the best way is just to light up a LED and turn it off again. Now, the ESP32 by default uses a C++ compiler. You can also use Java and Python through translations, but I just do it straight in C. And basically, the code I'm going to write would be to first do a setup and basically tell it that would what the pin's going to be and what the pin's going to do. So that's using a function called the pin mode, and you send in the pin number. Normally I'd use a constant, but to make it easier, I'm just going to show you as a number, and that's going to be pin 32, and it's going to be an output pin. For sensors, will be an input pin, like the moisture sensor, but we're going to be turning a LED on and off. We're going to be sending a signal out, and it's going to be an output pin. Then we close this off. Then basically we make a loop, and all we're going to say is, it's a digital. We're not doing analog. We're just doing it on and off. So it's a digital write, and we're going to digitally write out to pin 32 high, and that is basically put as much voltage as you've got out there. We're going to then wait 1 second, and that's done in milliseconds, so that'll be 1,000. And then we're going to digitally write again. This time we'll go to the lowest value, which is 0 volts. Okay, then we'll delay again for 1 second, and we'll close it off, and then we'll just loop back. Now, the ESP32 has 2 power pins. It can do it at 5 volts or 3.3. We're going to do it at 3.3. But there is a problem, and that is if we, first we'll upload it. So, you basically get this, fold it up, and upload it into the ESP32. So it's not really the way you upload it, but that's a nicer way to show it. Basically, the problem is we're going to run too much power into the LED, and we'll burn it out. So what we're going to have to do, if you remember from our last episode, is we're going to have to use a resistor to bring the voltage and the amps down. And real simple, basically, resistance equals the voltage of the power minus the voltage of what is being powered, which is the LED, divided by the amps used by the LED, which is in this case for a blue one, 25 milliamps. And out of that, we're going to get 8 ohms. And from that, we just go to 10 ohms because that's basically, I've got some 10 ohms resistors, and we're going to use that. And that is here. And here is the 10 ohm resistor. And to wire it up, this is a breadboard. We're going to use the long bit of the LED is an anode, the positive side. I'll put it there. We'll run pin 32. So that is here. We put him in here. We run that into this line here where the anode is. And in a breadboard, once you put it in, he runs the whole length down. See, they run down this way. Right, now that that's in, we run the resistor on the anode side here. We put him back into here. And then we got to run it to ground to complete the circuit. So the power goes somewhere. The ground is sucking the power away from the positive. And the ground is there. There's the ground pin. So you're actually using the ESP32 to ground it. You could use other things if you wanted, but just in this case, it's nice and easy to use the ESP32. Then we connect the power. And there we go. Every second he goes on. So that's just an example of a very basic digital circuit. And that's how it works. And we're going to basically use this brain to power all of Plantzilla. So I hope you enjoyed this episode. Any feedback, any comments, please let me know. And I hope to see you in the next episode. Thanks, guys, and take care. Bye.